Welcome back to Speller Tutorial Services. Today we're going to continue our talk on parametric equations. We're going to step it up a bit and actually use trig functions for this particular example. We're going to first, we're going to graph the parametric equations, and then we're also going to convert those parametric equations into a single rectangular equation. All right, so let's begin with, we have x is equal to 4 cosine t minus 3, and the other parametric equation is sine t plus 1, and the values of t are going to lie between 0 and 2 pi. Right, just like the last video, we're going to create a table where we can list our t values, our x values, and our y values. We're going to pick values of t that we can resolve by hand when substituting into these trig functions. So we're going to use 0, pi over 2, pi, 3 pi over 2, and complete the revolution around the circle ending at 2 pi. Alright, to help us and to also jog your memory, we're going to use the unit circle to help us come to these answers here by hand. So we start off with a circle that has a radius of 1, and we're going to first list the radians around the circle. So this here begins at 0 and 2 pi. Up here we're at pi over 2. To the left, pi, and then here 3 pi. Oops, and over here 3 pi over 2. Alright, the coordinates at this point are, the coordinates at this point are is 1, 0. Up here the coordinate is 0, positive 1. Back here it's negative 1, 0. And down here it's at 0, negative 1. And remember that the cosine values correspond to the x, and the sine values correspond to the y. So we're going to start off with just a basic substitution. So when t is 0, well, the cosine of 0 we know is 1. So we're left with 4 times 1, and we're going to subtract 3 from that. So 4 minus 3 gives us a positive 1. And matter of fact, I'm going to work on just the x values here to start, and then I'll go to the y values. Alright, the cosine of pi over 2. Again, we take the x value. The x value is 0. So we're left with 4 times 0 minus 3. So that resolves or evaluates down to minus 3. Cosine of pi is negative 1. So that's 4 times negative 1 minus 3, which gives us negative 7. Cosine of 3 pi over 2 is 0. So 4 times 0 minus 3 is negative 3. And then completing the circle at 2 pi, cosine is 1. And we have 4 times 1 minus 3, which gives us a positive 1. So there are all our x values. Now on to our y values. The sine of 0 is 0. So I have 0 plus 1 to give me 1. The 1 I'm starting there is the 1 here in the equation. Sine of pi over 2 is 1. So 1 plus 1 gives me 2. The sine of pi is 0. So again, 0 plus 1 gives me 1. The sine of 3 pi over 2 is negative 1. So negative 1 plus 1 gives me 0. And the sine of 2 pi again is 0. So 0 plus 1 is 1. So my coordinates are going to be 1, 1, negative 3, 2, negative 7, 1, negative 3, 0, and 1, 1. Before we graph, let's go ahead and do our rectangular coordinates. Alright, let's begin by rewriting. So we have x is equal to 4 cosine t minus 3. Let's add 3 to both sides because we want to get this cosine t by itself. So we're left with x plus 3 is equal to 4 cosine t. And now let's divide both sides by 4. And we have x plus 3 over 4 is equal to cosine t. Now let's work with the other equation. Y is equal to sine t plus 1. Let's subtract 1 from both sides. And we have y minus 1 is equal to sine t. Alright, we're going to lean on our knowledge of trig identity that sine squared t plus cosine squared t is equal to 1. And we're going to leverage that by squaring both sides of these equations. And then that's going to allow us to do to complete a substitution. All right, and we're squaring both sides because, again, squaring both sides keeps the equation balanced. So here, sine squared t, we see that's the same thing as y minus 1 squared. And then cosine squared t is the same thing as the quantity x plus 3 divided by 4 squared. And again, that equals 1. So here is our rectangular equation from those polar equations. Here we see, again, leaning on previous knowledge from conics and knowing how to graph those. This here is a graph of an ellipse. In this ellipse, we see that the major axis is the x-axis. So that means this ellipse is going to be stretched along the x-axis as such. And also we see that our center for this particular ellipse is going to be at -3, +1. We take the opposite sign of the x value and the opposite sign of the y value, and that's how I get the -3, +1 for the center of this particular graph. Now let's call up the calculator and actually complete the graph. Okay, let me go back. First, you want to make sure that the mode that you're in is in parametric mode. And once you've verified that, you want to actually go and put in your values for your parametric equations. And here we see that I put these in, but I made a mistake on the second parametric equation. That should actually be a +1. So we put in 4 cosine t minus 3. That's for x, and then for y we put in sine t plus 1, and then we click on our graph button to graph that. Alright, we have a pretty, the graph is not easily seen, so we're going to use the zoom feature on the calculator, and we want to do a square zoom. So we're going to go to 5, and then we're going to be able to pick a point. We'll pick 2 points and it's going to zoom in on it. So let's start on the upper left hand side. Click enter, and then that allows you to create a box. Oops, that should have allowed us to create a box. Let's try that again. Let's go to zoom and let's do 1 for zoom box 1. So let's click enter, scroll down, and then scroll right. So now when we press enter again, the calculator is going to zoom in on the box we've created here. So when doing that, we do see that we have an oval, and just to kind of freehand the center of the oval, we see that these numbers here are approximately what we have by hand. Let me just move these over so we can see that I originally stated that the center would be -3, 1. We see our x value approximately is at -3. Again, we're freehanding it, and then we see that it's up 1 unit, and that there is approximately 1. So that sums it up for this video from Speller Tutorial Services. Please friend us on Facebook and also subscribe to our YouTube channel, both found under the same name. Thank you again for watching.